So first up in this session, we'll be showing two Meru SDN application demos. And to talk about that and to show you these demos, it's my pleasure to welcome on the stage the Director of Product Management at Meru, Avi Bhaktani, as well as the Director of Engineering, SDN, and Applications, Lakshmi Dronadola. Please join me in welcoming Avi and Lakshmi.
Thanks, Neil.
Okay, we'll go cover a couple of slides in kind of give you a brief overview of what we're doing with Microsoft and with the Link application. And then we have a short 2 to 3 minute demo video that we have put together, and then we'll open it up for a few questions. So what is the Meru Collaborator? So effectively what we've done is we have created, and we'll show you the network diagram in a little bit. Meru Collaborator is an SDN application that configures and allows you to configure the right QoS policies across UC&C applications like Link, right? And it can be extended to many other applications, but this is focused specifically on Link and gives you the quality of service on a unified network for both wired and wireless. What you will see as part of the presentation and the demo is how we enable the wireless and the wired network with policies that allow you to, using Link SDN APIs. So Link, Microsoft has exposed SDN APIs, and using those APIs, we will basically initiate a call and create the end-to-end call with applying the policies through our own application called Meru Collaborator. This is a quote from Pascal at Microsoft. You know, he's also very active in the Open Networking Forum. And he quotes, right, Meru is the forefront of SDN by OpenFlow enabling access networks, increasing IT department speed and agility, and eliminating vendor lock-in. And again, very key point here, and this is why the attraction of Microsoft and Meru as a partner. Microsoft's goal is to make sure that the user experience for Link is the prime is at the forefront of the applications, right? So the goal is to basically make sure that any user using Link can guarantee the end-to-end quality of service, right? And we'll show you in the demo how we do that.
Okay. To add a few words on that, right? I mean, like any other application, the problem with the UC&C applications or any other applications, right? You can see that unified deployment of the application is very hard. I mean, when you go to a UC&C kind of applications, you need to have like a lot of ACLs, a lot of lead time to check your network, deploy all the network policies, and it doesn't work. I mean, when someone brings a new device, those kind of static policies you need to apply. But what you're enabling is like with Meru Collaborator, it will be like a zero-touch deployment of your Link UC&C applications in an enterprise. It's mostly like, okay, you can define your application policies at a high level, and we convert them to a Link level policies and provide an end-to-end bandwidth dynamically.
Yeah, so what you can see in this network diagram is basically we have our Meru MC4200 controller and our access points connected on one end of the network. And we have a SDN-enabled OpenFlow switch on the other side of the network. And you will see a demo of this shortly after lunch as well. And what we do here is basically we have OpenFlow enabled on both sides of the network. And when a call initiates, you have a Microsoft Link basically accepting the call, which is the dotted line is the control, the control actions, right? And with the Meru Collaborator, we push down policies that gives you the guaranteed bandwidth between a call initiated on a wireless device and on a wired device. So that is kind of the effectively end-to-end architecture.
So the SDN API here is like Microsoft released this almost a year ago, and now this is getting standardized in ONF NBI forum, where Pascal is really involved there. So this is kind of like not only for Microsoft Link, but it's just generally a UC&C forum suggesting these kind of APIs where you can see that where the call is initiated and what type of call and what is the ports, so that you can go and deploy, listen to those events and go and deploy your policies based on your enterprise need.
So some advantages, right? And we've talked through this session, open flow standards base, again, that's key. And as Lakshmi pointed out, these APIs are being standardized, right? The link APIs as well, end-to-end flow control. And then you have a single pane of glass. So what you'll see as part of the demo, and also what you will see as part of the video, is that you will, you can actually see your end-to-end network. We use Open Daylight here, but pretty much any SDN controller will give you the same view of the network. And of course, integrated with Microsoft Link SDN APIs. Let's go to a quick demo.
Today, wireless is not only a requirement, but is becoming the primary access network for the end user. With growth of Wi-Fi devices and applications, we don't have staff or time to configure every wired and wireless networking device. Today's networks need to be simple, open, and easy to configure. That's why we're interested in the SDN technology that data centers are now using. However, the SDN solution is limited to only wired networks. This creates a huge gap for us, since about 40% of our network devices are wireless. What we need? A solution that'll increase end user experience for both wire and wireless.
Software-defined networking, or SDN, enables the network to be dynamically controlled and configured. Meru understands that there's an urgent need for end-to-end solution and is bringing SDN to the wireless edge to enable application performance, ease of management, and simplicity of use across the unified wired and wireless access network. Here in our Meru SDN solution demo, we have a Meru controller along with a Meru access point that's connected to an HP ProCurve switch. We also have an Open Daylight SDN controller along with a Microsoft Link server. In this demonstration, we're going to achieve SDN with multi-vendor, wired, and wireless network. Our switch and our wireless controller are open flow enabled, which allows us to see a complete network topology, achieving a unified view of the network. Our network is now ready for policy and deployment and optimization from end to end, wired and wireless. Microsoft Link server is deployed in this demo, and we're going to actually be demonstrating a call from a wired to a wireless user. Link is used in the enterprise environment due to the many collaboration features, allowing the employees to be more productive. It allows text, video chat, file share, and also screen share. So here we're going to make a Link call between a wireless iPad with a wired laptop. Here you can see I'm connected to my coworker, Lakshmi, and you can see that the video has already frozen. Now, this type of quality is extremely poor and most likely not going to be accepted in most enterprise environments. What we do with Meru and our SDN application is we have the ability to now enable QoS from end to end. So here I will click a video call, enabling QoS for the video call. As you can see, as soon as I enable the quality of service policy control, the quality of this call, the performance has extremely increased.
With Meru Network's SDN solution, our customers receive higher performing networks with end-to-end application quality of service and network-wide unified policy enforcement, unified wired wireless management, best-in-class product solutions which are vendor agnostic. Only by enabling full visibility and control over their unified networks, both wired and wireless, can IT administrators truly deliver the promise of SDN.
All right, any questions?
Do you have any sort of, I'll speak loudly. you have anything in the controller in terms of reporting that measures, say, client health against call quality?
Okay, let me take this question. So we will be showing that in the demo. So the diagnostics part of the application, right? So that diagnostics, we are collecting it from multiple sources. So from the OpenFlow, we just use OpenFlow to configure the network, provision your network. But how do you get the diagnostics? I mean, we do SFlow to get the diagnostics, and we do some of the OpenFlow port statistics to see like when the call is going bad. And you can drill down to the call and see like where exactly the problem is. You can see the topology, end-to-end topology, click that particular node where the problem is and see what's happening when the call is going on at that particular time.
So if I'm running a help desk engineer can look at a single pane of glass and say, is this a link problem? Is this a wired network problem? Or is this a wireless network problem?
Exactly.
Yeah, and that's where you hit the nail on the head, right? Because now you can actually go from, and which was the biggest attraction even for Microsoft, is now I can, as an application player, I can look at the network end to end and pinpoint exactly and troubleshoot where the issue is.
Could you elaborate on the Link SDN API integration, like how you guys go about that?
So the Link SDN API integration, as I told previously, I mean, the Link, Microsoft came up with this concept of SDN API. It's not really a API which is SDN, but it is facilitating SDN applications to provision automatic networks. So they released it in 2003 around, I think 1.2 was the first release. Now they are at 2.0. And we started using that, and we started following it up. And these particular Link SDN APIs now are getting standardized in ONF NBI. And these are the ones which are going to be used across the UCNC community. So say like today's Link application, tomorrow some other application, they will be exposing the same details, and your application can go ahead and provision the network accordingly. Does that answer your question?
Yeah, so basically the Link LSM will talk to your controllers.
Oh, okay. So Link doesn't talk to the controller part Axel, but it talks to the applications. What it does is like Link posts the registered applications. You can register multiple applications to Link server. What it does is like whenever a call comes, it posts a REST call. It's a HTTP call. It posts the REST call to your application. So it says like, okay, someone is calling from A to B, and this is the call details. And rest of us left to you, how do you handle that? Do you want to you don't want to give a best video experience for everyone, right? When there is an important call going on, so you wanted to take care according to your enterprise needs, which calls need to be prioritized.
So since Microsoft SDN APIs came out, a lot of vendors have been talking about Link SDN apps that they have released, and they've marketed them. So how is this Meru Collaborator different from what everyone else is offering, and why was Microsoft so excited about this?
Great question, right? So since Link came in, and you can go to SDN API and see like Microsoft Link already have some vendors where the SDN API applications based on SDN API are built. But what is missing here is, again, the same problem of like vendor lock-in. So those applications work specifically on those devices, whoever the developer, right? It works only in those environments. But what we are trying and what we are doing here is like using the OpenFlow to eliminate the vendor lock-in, and now we can see as the demo demonstrates, and we can show the demo, and then the breakout session also. So we can see like it is vendor independent. I mean, you can have a wired vendor from a different company and wireless vendor from a different company, but we can go ahead and deploy the policies. It's truly open SDN application. So that's where actually the differentiation between the previous applications, and that's why Microsoft is interested to look at like how we can deploy this across the network, right? Across the unified network from multi-vendor environment.
Yeah, the challenge like application players like Microsoft and some of our partners in the room have is that unless and until they can get a standardized way of running policies across networks, it becomes very challenging because every network product is going to be different. So even if they have Link SDN APIs, they will have to basically use their own either CLI or SNMP or some kind of other tools to basically configure the policies on the network. And then that changes when you have the next vendor, and changes when you have the next vendor, and so on and so forth. With OpenFlow enabled on all the devices, you get Link SDN APIs which are standardized, and then OpenFlow policies which are standardized, effectively giving you full control on the network. And that is the biggest attraction for players like Microsoft.